Hello everyone and welcome to the chapter 3 of TMUA simplified, and that is binomial theorem. It's a very important topic because every year you get at least one question from binomial theorem. It can range to 2 also, right? So let's understand this. Now what is binomial theorem? Binomial theorem is basically an expansion of x plus a to the power n. X plus a to the power n, the expansion of this. So as we know, the expansion of this is nc0 x to the power n a to the power 0 plus nc1 x to the power n minus 1 a to the power 1 plus nc2 x to the power n minus 2 a to the power 2. So as you can see that power of x is decreasing by 1 and simultaneously the power of a is increasing by 1 in the preceding succeeding terms, right? So if I carry on like this, so the second last term will be ncn minus 1 x to the power 1 a to the power n minus 1, and the last term will be ncn x to the power 0 a to the power n. So this is binomial theorem. Now how do we come to this, right, is the question, right? Although I can mug up this expansion and I can do questions as well on this, but it is imperative that I should understand it, why this expansion is there in the first place, why these nc0s, nc1, which we call coefficients, are there, right? Now x plus a to the power n means x plus a into x plus a into x plus a, how many times? Say n times. There are n brackets x plus a. Now when I multiply, I take a term, one term from a bracket. So suppose I'll take all the x from all the brackets, right? So I will be getting x to the power n. But just to generalize, there are n brackets. I'm taking all the x from the brackets and I'm not taking any of the a from any of the brackets. So I can say that nc0 is the number of way of selection, number of ways of selecting 0 things out of n, right? That we have covered in combinatories, but this is what we know already, right? And we also know that what is NCR. Just remember, NCR is factorial n upon factorial r into factorial n minus r. This result should always be remembered in the binomial. Otherwise, there will be a problem solving the coefficients. So what does this mean? That from n brackets, since I've selected all x, so I haven't selected any of the a's, but the number of ways of selecting no a from n brackets is nc0. Similarly, if I take one a from a bracket and from rest all brackets, if I take x, so in number of ways of selecting one a, because I don't know from which bracket I am taking a. So the term like x to the power n minus 1 a, because I have taken 1 a and from rest of the n minus 1 brackets I have taken x. So the product will become x to the power n minus 1 into a. But this is going to happen a lot of times. Why a lot of times? Why? Because if I take a from this bracket and remaining x from the other brackets, so this will be one such term, right? But this will be multiple times. Why? Because if I take x from this, a from this, and remaining all the x from the remaining brackets, then also I'll get the same term, right? So I will be getting the same term a lot of times. And how many times? This depends on the number of ways of selecting a from n brackets. So if I'm taking one a from n brackets, so number of ways is nc1. See, a lot of people can argue why I am not taking in terms of x. Yeah, it's same. It will be same. You can take in terms of say x also, because there is a property NCR is same as NCN minus R. Right. So the term here NC1 x to the power n minus 1a, if I do it in terms of x, so that will be the second last term of this expansion. So it doesn't matter, right? You are selecting in terms of a or x, because if you have selected x from one bracket and remaining brackets you are selecting a, so it's natural. You don't have to make a selection at that point of time, right? So nc1 x to the power n minus 1 a, right? Now if I'm selecting two a's from two brackets, so number of ways of doing it is nc2, right? So a will become 2 and x will become n minus 2. So from rest all brackets I am taking x, and so on and so forth. So the last term will be when I'm selected all the a's, and that means I have not selected any of the x. So this becomes the last term. So this is how we come to this expansion, right, which is very important to understand. Just mugging up the expansion won't help our cause, right? So this is what you should understand, right? Now coming back to the expansions once again, x plus a to the power n is nc0 x to the power n a to the power 0 plus nc1 x to the power n minus 1 a to the power 1. So if I generalize and look at the general term, so what is the general term of this expansion? Now the general term of this expansion, any term, right? General term means any term. Since this is starting from 0, so if I say NCR, general term is, I'll put TR plus 1. Why? Because see, R is starting from 0, so first term will be by putting R equal to 0. So that's why I'll say R plus 1 and not R. Why? Because R starts from 0. So if I put a 0 here, so it will be 0th term, which doesn't make any sense. So that's why I'm not taking TR, I'm taking T of R plus 1, which is NCR x to the power n minus R and a to the power R. So this is the general term of this expansion. Like if I have to find the fifth term of this expansion, so I will put R as 4, because 4 plus 1 is 5. So T5 will be NC 4 x to the power n minus 4 and a to the power 4. So this will be the fifth term, not the fourth, but the fifth term. Since R starts from 0 to 0, 1, 2, 3, 4 will give me the fifth term, right? So this is something which you have to understand. Okay, now let us look at another expansion. Now here it is x minus a to the power n. Now if I expand this, I will be getting nc0 x to the power n minus a to the power 0 minus or plus, okay, nc1 x to the power n minus 1. Now I'll take minus a to the power 1, which will give me a negative term. Minus 1 to the power 1 will be minus a. So the second term will become negative. So alternately you will get positive, negative, and so on, depending on what n is, right? So next term will be nc2 x to the power n minus 2 minus a to the power 2. Now this will again become positive, and so on and so forth. If I write the last term, it will be ncn x to the power n minus n, which is 0, and minus a to the power n. So the last term will be positive or negative depending on the n is odd or even. So if n is even, the last term will be positive. If n is odd, the last term will be negative. So this is another expansion. So if I have to write the general term of this, so I'm going to say TR plus 1 equal to NC0 x to the power n minus R and a to the power R, and in I will also put minus 1 to the power R. Minus 1 to the power R will adjust the sign of this term. So if R is odd, it will give me a negative term. If R is even, then it will give me a positive term, right? So these are the general terms of these expansions which one should remember, right? Now let's understand through few applications. Now they're saying that find x to the power 4 in the expansion of 1 plus 2x to the power 9. Now I know if I look at my expansion general term tr plus 1, so I will be getting NCR, that n is I know is 9, 9CR 1 to the power 9 minus R 2x to the power R. Now in order to find x to the power 4, I'll put R as 4. So R as 4 will give me the fifth term of this expansion, which is NC5 1 to the power 9 minus 4 is 5 and 2x to the power 4. So the coefficient will be 9C5 first of all, and 1 to the power 5 will be 1 only, and 2 to the power 4 also I have to take. 2 to the power 4 is 16. So this is the coefficient of x to the power 4 in this expansion. So such questions are there. So please be aware of it, that you have to take the general term and whatever the power of x is, you have to put in place of r, and then you have to check the coefficient. Now what is 9C5? 9C5, as I told you, NCR is n factorial upon r factorial into n minus r factorial. So this will be 9C5 will give me 9 factorial upon 5 factorial and 4 factorial. Now how do we solve it? So I know 9 into 8 into 7 into 5, 6 into 5 into 4, or 6 into 5 factorial is what I can write. So into 5 factorial upon 5 factorial into 4 factorial. 5 factorial get cancelled. So 9 into 8 into 7 into 6 divided by 4 factorial is 24. So this is 3, this is 3. So 3 sevens are 21, 21 into 6 will be 6, 126. So 126 into 16, 16 6 is 96, 16 2 is 32, 41, 2016 is the answer. So this is how we can find coefficient of a term in a binomial expansion, right? I hope you have understood this. Okay, now let us look at this problem. This problem is very important. It has come numerous times in TMUA, right? So let's understand the process of it. Now they say find the term independent of x in the expansion of this. So I'm going to write the general term tr plus 1 will be 6cr 2x to the power n minus 6 minus r, sorry, and minus 1 by x square to the power r. So this is what I will be getting. Now this will give me 6cr 2 to the power 6 minus r and x to the power 6 minus r, and it will give me minus 1 to the power r separately and x to the power 2r. So this is what I'm going to get. Now let's solve it a bit, right? So this will give me 2 to the power 6 minus r minus 2, same, right? Then just a minute. Okay, right, let's proceed. So x to the power 6 minus r minus 2r and minus 1 to the power r. So this is what my term is. Now if the term has to be independent of x, then the power of x should be 0. So I'm going to put the power of x, which is this, as 0. So I'm going to get 3r equal to 6. So r will be 2. So r is 2 and I know my general term is tr plus 1. So actually the third term will be independent of x. So if I put r as 2, I'll get the third term, which will be 6c2, 2 to the power 6 minus 2 is 4, and obviously this will become x to the power 0, and minus 1 to the power 2 will give me a positive term. So it will be, now 6c2 will be 6 factorial upon 4 factorial 2 factorial, 2 to the power 4 will be 16. So eventually I'm going to get 6 into 5 by 2, which is 6 into 5, 30 by 2 is 15 into 16. 15 into 16 will be, I know 15 square is 225, so I'll add 115 more to that, give me 240. So 240 is the third term and it is independent of x. Right. Okay. Let's do some different type of questions using binomial. This is number based, like 7 to the power 23 when divided by 6, what is the remainder? Now, this seems very complicated. How can I find 7 to the power 23? But if I use binomial and if I say I can always try to break the number as divisor plus 1 or divisor minus 1. Divisor plus 1 or divisor minus 1, or you can also write multiple of divisor plus minus 1. So 7 can be written as, and the divisor is 6, so it can be written as 6 plus 1. Now, if I use binomial theorem to expand this, so it will give me 23C0, 6 to the power 23, plus 23C1, 6 to the power 22 into 1 to the power 1, plus 23C2, 6 to the power 21, 1 to the power 2, and so on. The second last term will be 23C22, 6 to the power 1, 1 to the power 22, and the last term will be 23C23, 6 to the power 0, 1 to the power 23. So this is what I've got. Now, once I've achieved this, I know if I divide this entire expansion, this is 7 to the power 23 is nothing but this, which is this. So if I'm dividing 7 to the power 23 by 6, so in a way I'm dividing this whole expansion by 6. And you can see the every term has a power of 6 till the second last term. So all these terms will be divisible by 6. So my remainder will come from the last term. NCN, that is 23C23 will be 1, 6 to the power 0 will be 1, 1 to the power 23 is 1. And 1 is smaller than 23C. So if you divide 1 by 23, remainder will be 1. Right? So this is how we can do numeric based questions using binomial theorem, especially when they're asking for the remainder, right? Okay. So the idea behind this question is to break the base of the exponent as divisor plus 1 or divisor minus 1. If not that, then multiple of divisor. Like if suppose 6 was, suppose 6, suppose it was 13 to the power 23, then I would have written 12 plus 1. Right? In case of 13 to the power 23, I could have written as multiple of 6, which is 12 plus 1. Now, if 6 is divisible by 6, so 12 is also. So the same logic works for 12 as well, right? Now, let's look at this. Now, this is a little tricky in a sense that it's 2 to the power 23. It is not directly divisor plus 1 or divisor minus 1. It's a smaller number. But I can make it close to 17 at a difference of 1, divisor plus 1 or divisor minus 1, which is possible. I know 2 to the power 4 is 16. So I'll be looking at, and 16 is 17 minus 1. So this is what my thought process should be. But in order to make it 16, the power should be 4. So I'll say 2 to the power 4, right? So the closest multiple of 4 nearest to 23 will be 20. So I can write it as, this will be 2 to the power 20 into 2 to the power 3. That will give me 2 to the power 23. See, I have to make the power a multiple of 4 because I have to make it 2 to the power 4. So in order to make it a multiple of 4, I know the multiple of 4 closest to 23, lesser than 23 is 20. So I've written 2 to the power 20 separately and 2 to the power 3, and 2 to the power 20 I can further write it as 2 to the power 4 into 2 to the power 5, which will be 16 to the power 5 into 23, and 16 can be written as 17 minus 1 to the power 5 into 8. Now I know the remainder of this will be the last term, As I can see, if I write the expansion, it will be 5c0, 17 to the power 5, minus 1 to the power 0, and so on. And if I look at the last term, only the last term will give me the remainder that I've expressed in the last, because all the other terms will be divisible by 17, since all of them have a power of 17, except the last term, 5c5, 17 to the power 0, and minus 1 to the power 5. This will give me minus 1, and outside we have 8, so the remainder will be minus 8. Now the remainders cannot be negative, so a remainder negative means that much less than the divisor. So remainder of minus 8 means it's minus 8 less than 17. So just add 17 to minus 8, you'll get 9. So remainder will be 9. Remainders are never in negative, so if remainder is negative, just add the divisor to it. So minus 8 plus the divisor 17 will give me 9. 9 is the remainder. Let's look at one more. Now this is bigger than 7. It's not smaller. So to make it close to a power of 7 will be very difficult. So let's make it first smaller. So I can write it as 21 plus 4, since 21 is a multiple of 7. So in this expansion, the last term will be, because I know all the terms will be divisible by 7, because all the terms till the second last term will have a power of 21 in it if I write the binomial expansion. But the last term will be 25c 25, 21 to the power 0, and 4 to the power 25. Now, here I cannot say that it will be 4. It's 4 to the power 25. 1 to the power anything is 1. I know that. But 4 to the power 25 still is a very big number. So my question changes to 4 to the power 25 when divided by 7. What is the remainder? So I made it a little smaller. Now I know the power of 4 which is closest to 7. I know 4 square is 16 and 4 cube is 64. 64 can be written as 63 plus 1, and 63 is a multiple of 7. So I can break it like this. So what I will do is, I will first make it 4 to the power 3. So for that I need to make it a multiple of 3. So the closest multiple of 3 close to 25 is 24. So 4 into 4 to the power 24 is what I can write. And then I can write it as 4 to the power 3 whole to the power 8, right? And this will be 64 to the power 8. And then 64 can be written as 63 plus 1 to the power 8. Now I know the last term here will be 8c8, 63 to the power 0, 1 to the power 8. So remainder will be 1, but outside there is a 4. So answer will be 4. So 4 is the remainder. So this is how we can tackle problems on numbers using binomial theorem. I hope you understood most of it, right? Towards the end of the exercise, there are some questions which I have compiled, right? Do them, and then towards the end there will be a video solution of it. Those are very important questions from TMUA point of view. Make sure you do them, right? Take care. See you next time.